Welcome to our notes about determinant applications. If you have not watched 2.5, go ahead and do that first because you already have to know how to find a determinant in order to understand these notes. The first application we're going to talk about is a 3 by 3 determinant application, and it helps you find the area of a triangle. So, if you take yourself back to geometry class, you might remember talking about how to find the area of shapes on a grid like this. So, not just like any shape where the sides are marked, but a shape where you actually have to count out the distances or lengths. Let me fix this really quick. Perfect. So, finding the area of a triangle is pretty easy if you know how long each side is, but it's actually pretty difficult if you only know the coordinates because you would have to use the distance formula to count how long each of these are. Hopefully, you're aware that the area of a triangle is 1/2 base times height. And finding the determinant of a matrix actually helps because it takes care of this part right here. So it takes care of the base times height for you. This is the formula over here. Remember that these long lines that are like a matrix without the little feet on the ends, this means determinant. So if you find the determinant of the matrix and multiply it by 1/2, then you have the area of the triangle. Now you might notice that there's this weird plus minus out front. This is used to make sure that the area is positive. So sometimes when you do this, you're going to get a negative answer. That means you'll multiply it by negative 1/2 to make it positive. If it's already positive over here, then you'll multiply it by positive 1/2. So we don't really do much with this plus or minus other than make sure that we give each shape a positive area. So it's really just there to fix a little kind of glitch that happens occasionally. So what we're going to do is find the area of this triangle. And what you'll notice is if you write the points out, this one's over 1 up 6, over 7 up 1, and over 3 down 1. Make sure you're writing your points with x first, then y. What you'll notice if you make a matrix out of these is we're going to have a x column and a y column, just like we did with our systems. So 1, 6, 7, 1, and 3, negative 1. What you'll notice is I have three rows and only 2 columns. But yesterday, or in the determinant notes, I said you could only find the determinant of a square matrix. So because there are only 3 points, and each point has an x and a y, and you can only find the determinant of a square matrix, we add this column of all ones at the end. And it does make a difference that it goes at the end, by the way. So here is my matrix, and what we're going to do is multiply the determinant by 1/2. And this is the part where you need 2.5 or determinants, because it tells you that you're going to take these first 2 columns and copy them down. And then you're going to find the product of each of the right diagonals. So here is 1. 1 times 1 times 1. Here's another one. 6 times 1 times 3 is 18. And the last right diagonal, 1 times 7 times negative 1 is negative 7. And you're going to add all of those together. 1 plus 18 is 19, minus 7 is 12. And then you're going to do the same thing for the left diagonals, the one that starts in the middle and goes to the bottom left. And you're going to subtract these all added together from this one. So you're going to do 12 minus whatever answer we get from adding all these together. So 1 times 1 times 3 is 3. Careful with these negatives. 1 times 1 times negative 1 is negative 1. And 1 times 7 times 6. 1 times 7 is 7. 7 times 6 is 42. So realize that it does not matter what order you multiply in. 1 times 7 times 6 and 6 times 7 times 1 are all the same thing. And 3 minus 1 plus 42 is 44. So you're going to take the one you got first, 12, minus the new one, 44. And then to find the area of the triangle, you're going to multiply that by plus or minus 1/2. Since 12 minus 44 is a negative number, it's negative 32, you're going to multiply negative 32 times negative 1/2 so that it turns into a positive 16. So basically you make this negative if this is negative, you make this positive if this is positive. So we've got 16 units squared. So you're still doing the determinant like yesterday, you're just multiplying that by 1/2 or negative 1/2 afterwards. That's it. And the thing is, you don't actually need to be able to see the graph to do this. You can actually just do it from 3 separate points. It doesn't really matter what order you put them in, but I'm going to keep them in order. -7, -5, -2, 8, and 6, -2. And then you keep your column of all ones at the end. And we're going to multiply this determinant by plus or minus 1/2. So to find the determinant, you copy down the first 2 rows or first 2 columns, just like we talked about in 2.5. And then you're going to multiply all of the right diagonals, starting with the top left, going down into the right. So you're going to multiply all of those numbers together. -7 times 8 is -56, times 1 is still -56. -5 times 1 is -5, times 6 is -30. 1 times -2 is -2, times -2 again is +4. And 56 minus 30 plus 4 is -82. And then you do the same idea, but you need the left diagonal instead. 6 times 8 is 48, times 1 is still 48. -2 times 1 is -2, times -7 is now +14. And 1 times -2 is -2, times -5 is +10. So we've got 48 plus 14 plus 10. That is going to be 72. Start with the first one you got and subtract the second one you got. -82 minus 72 is -154. And then you have to do this plus or minus 1/2. Since this is a negative, I'm going to want to multiply by -1/2. And that leaves me with 77. Half of 154 is 77. Oops, units squared. Don't forget to add your units squared to the end. Now let's talk about Cramer's rule. So Cramer's rule gets to use 2x2 determinants instead, which is nice because you don't have to do the extra columns with this one. Basically, you can use the determinants of the augmented matrix for a system of equations to solve the system without row operations or a calculator. And if you don't know what row operations are, that is A-okay. So what we're going to do is we're going to be taking individual determinants. Also, I'm realizing now as I'm saying this, I'm missing a C2 right there. So I'm using letters for right now just to show you. It goes A, B, C, and in the first equation I'm putting little ones next to them, and in the second equation I'm putting little twos next to them. The 1 stands for first equation, the 2 stands for second equation. So let's say we wanted to find out the value of x. We would divide dx by d. If we wanted to find out y, we would do dy divided by d. Okay, now you might be like, what in the heck is she talking about? Well, you'll notice that dx is missing, and actually this should just be x equals and y equals. There we go, that makes a little bit more sense. This is the constants from the end of the equation. So they go in the first column, and the second column is the y's. So it's almost like you took out the x part, or the x column, and you swapped the other two. So if I wanted to do that here for this one, I would do the constants first, 22, negative 6, and then the y's, negative 5, 7, over D. This D stands for the determinant of everything with the variables. So I'm going to write variables above. Because if you take away the x and the y and you make it just those two, that's what matches here. So if I covered up the constants down here, let's do it this way, there we go. I have 3, negative 5, 2, 7. And if I do these two determinants and divide them, that's going to be my x value of the answer to the equation. And I'm going to go ahead and do that first, and then I'll explain to you how to do y. So when we were talking about determinants of 2 by 2's, it's this product minus this product. So 22 times 7 is 154, there we go. And then over here, negative 6 times negative 5 is 30, and you subtract them. 154 minus 30 is 124. And then over, you do the same thing here. 3 times 7, 21, minus 2 times negative 5 is negative 10. And when you subtract a negative, you end up adding. So that's 21 plus 10, or 31 on the bottom. 124 divided by 31 is 4. So x equals 4. Now, I'm going to be really honest, you have two choices. Either plug 4 back into one of the equations, or do a similar process for y. For y, you'll notice that it uses sort of like the x column and the constant column. So you're eliminating the y column, basically. So you're covering up those y's, and you're going to go 3, 22, 2, negative 6. But the bottom part is the exact same. So instead of writing all of this out again, 3, negative 5, 2, 7, I already know that this bottom determinant was 31, so I'm going to reuse it. So they both have the same number on bottom, it's just on top, you either use the constant column and the y column for x, or the x column and the constant column for y. If I wanted to do this determinant, I would do 3 times negative 6, which is negative 18, minus 2 times 22, which is 44. And negative 18 minus 44 is negative 62. So y is negative 62 over 31. which is -2. So my answer is x equals 4 and y equals -2. And I can double check. 3 times 4 would be 12. -2 times -5 would be 10. 12 plus 10 is 22. 2 times 4 would be 8. 7 times -2 would be -14. 8 plus -14 is -6. So it works. It finds the answer. Just instead of doing elimination or typing it into a calculator, you can use determinants. Let's do one more so I can go through the process a little bit quicker. For x, you're going to do the determinant of the constants, 68, 32, and the y's, 10 and -2. You just have to put the constants first. Think of it like you're subtracting these y's over here so that x is all by itself. Over the determinant of just the variable side. So don't do the constants at all. 3, 10, 7, -2. Y will be the x column in the constant column. So 3, 68, 7, 32. Over whatever number we get from over here. So these two should be the same number. So I'm not going to write it yet so that I can fill in the number when I get it over here. So let's actually do the determinants. 68 times -2 is -136. And 32 times 10 is 320. And we are subtracting. So this product minus this product. -136 minus 320 is -456. Whew. Then on the bottom we have -6 minus 70. And -6 minus 70 is -76. And -456 divided by -76 is 6, guys. All you have to do is take out a calculator and calculate it out. Now that I know that -76 is my number on the bottom over here, all I have to solve out is 32 times 3, which is 96, minus 7 times 68. And 7 times 68 is 400 and 1 second. 76. And 96 minus 476 is -380. And -380 divided by -76 is +5. And those are my answers. If I plug in 6, this is 18. If I plug in 5, this is 50. 18 plus 50 is 68. 7 times 6 is 42. Minus 2 times 5 is 10. 42 minus 10 is 32.